The theme of our report is effects of sodium metasilicate on the early age hydration and certain behavior of alkali-activated common cements containing slag. The work was done by a group consisting of Professor Kryvenko Pavlo, Professor Rudenko Igor, Associate Professor Gelevera Oleksandr, and Associate Professor Konstantynovskyi Oleksandr. The actuality of common cements containing slag implementation is due to their conformity with ecological, economic, and technical aspects of sustainable development concerning efficient consumption of raw materials and energy resources, responsible attitude to the ecology of the environment, durability, etc. The main problem of using common cements containing slag is slowed hydration processes and, as a result, lost early compressive strength. The best solution for activating such cements is alkaline activation. Sodium silicates, the anions of which are similar to hydrated initial products of destruction of the alumina-silica-oxygen framework and serve as their additional reserve, are found to be the most effective alkaline activators. The best solution is the use of sodium metasilicate pentahydrate due to its constant composition, market availability in a solid state, and easiness in use in the process of cement and concrete manufacturing. Increased slag content in cement systems and alkaline activation provide formation of more preferable hydration products, cause high strength gain and durability. The main obstacle in using the alkali-activated common cements containing slag made with sodium metasilicate is a quick setting. The use of setting retarder, effective in alkali-activated cements, for example, sodium lignosulfonate, can be a way to control their structure formation processes. So, the aim of the study was to discover an approach to control the structure formation in alkali-activated common cements containing slag through alkali activation with the help of sodium metasilicate. Raw materials: granulated blast furnace slag, as well as Portland cement, CEM1 42.5R, were used as basic constituents of the common cements containing slag. To evaluate the basicity of the cement systems under study, a modulus of basicity as a ratio of masses of oxides was applied. Used in the study were three cement systems, the compositions of which are given in table. That was previously demonstrated by Brunauer, Spinova, Sanitsky that the alkali-activated cement system number 1 couldn't be used due to extremely quick setting. It was shown that calcium sulfate dehydrate, a setting retarder, is leaving out of structurization initial time of hydration as a result of exchanges reaction with alkaline metal compounds. Decrease in basicity of cement system and use of surfactants can be a decision to provide required setting times of such cement. Used as an alkaline component was sodium metasilicate in a solid aggregate state and a liquid aggregate state. Sodium metasilicate was added in two aggregate states, both in equal quantities, worth 12% calculated on dry matter. Sodium lignosulfonate was used as an acetylene retarder in the form of concentrated solution. Testing techniques. The compressive strength of the cements was determined by EN 196-1 with the following amendment. A water to cement ratio was chosen in such a way that its consistency, evaluated by flu, would be 115 millimeter against a standard water cement ratio 0.5. The heat of hydration of cement paste was measured using a modified semi-adiabatic calorimetry. The research work was divided into three parts. Task 1. Research the influence of basicity of the cement system. Sodium metasilicate was used in solid form. It was shown The decrease in the alkali-activated cement system basicity from modulus basicity 2.5 down to 1.2, the structure formation processes retarded. An increase in the duration of the induction period, as well as a decrease in the degree of hydration, confirm this fact. Alkali-activated cement system containing 5% of slag is characterized by extremely quick setting times and low strength that correlated with the date concerning the problem of its application. Increase in slag content in cement system from 5 up to 95% accompanied by an increase in initial setting times from 8 up to 100 minutes and final setting times from 11 up to 130 minutes. The obtained results correlate well with the date of the thermokinetic analysis. With increasing the slag content from 5 up to 30, 95%, the compressive strength of the alkali-activated cement systems at an age of 2 days increased from 4 up to 34 MPa. At later ages, with increasing the slag content, the compressive strength also increased at an age of 7 and 28 days from 9 up to 33 MPa and from 12 up to 65 MPa agreeably. Task 2. Research the influence of the aggregate state of sodium metasilicate. The use of sodium metasilicate solution instead of powder injures intensification of the early structure formation processes due to changes of thermokinetic characteristics. This can be attributed to the fact that in the case of powder, a certain time is required for the dissolution of sodium metasilicate in mixed water and its involvement in structure formation processes. In the case of sodium metasilicate solution, these processes occur and start to develop immediately and with a high intensity. The comparison of the setting times of the alkali-activated cement systems made with sodium metasilicate solution and with powders showed the quickest initial setting times in the case of solution within the range of 1-8 minutes. These initial setting times were too short and could not be accepted for the alkali-activated cement system. Alkali-activated cement system containing 5% of slag in case of solution is characterized by still lower strength if compared with powder. The use of sodium metasilicate solution compared to sodium metasilicate powder resulted in high compressive strength of cement system containing 95% of slag at age of 1, 7, and 28 days, 43, 51 MPa, 88, 92 MPa, and 108, 115 MPa agreeably. The obtained results testify to a necessity to decelerate the rate of structure formation in the alkali-activated cement systems for the whole range of contents of the slag constituents made with sodium metasilicate solution to provide the acceptable setting times. Task 3. Research the influence of sodium lignosulfonate on the structure formation. The influence of the sodium lignosulfonate admixture was studied using alkali-activated cement with modulus basicity 1.2 made with sodium metasilicate solution with account of its weak setting. The quantity of sodium lignosulfonate was 4% by mass of the cement. Decrease in duration of the induction period as well as increase in rate of hydration and degree of hydration reflect the retardation of structure formation processes. With the use of sodium lignosulfonate, the initial setting times of alkali-activated cement systems with modulus basicity 2.5, 1.7, and 1.2 made with sodium metasilicate solution increase from 1 up to 17 minutes, 4 up to 38 minutes, and 8 up to 60 minutes respectively. The initial setting times of alkali-activated cement system with modulus basicity 1.2, 1.7 are rather appropriate. The addition of sodium lignosulfonate to alkali-activated cement system made with sodium metasilicate solution resulted in some decline of the compressive strength compared to those of the admixture-free cement composition. The strength of alkali-activated cement system with modulus basicity 2.5 is still low. Thus, it was revealed alkaline activation with the help of sodium metasilicate in liquid form, in contrast to dry form, while necessarily decrease in modulus of basicity from 2.5 down to 1.2, 1.7, as well as application of sodium lignosulfonate, a setting retarder, injures to control of early structure formation that resulted in the obtaining of quick quad-hardening alkali-activated common cements containing slag with regulated initial setting times 38, 60 minutes and high strength gain similar to that of high alumina content. Thank you for your attention.